Yeah, hello friends. So today we are going to do a few issues regarding linker stuff, and then I think there's one GC feature, and then hopefully, yeah, exactly. There's one thing on read-only span overloads and compare info, and then I think it's backlog. So we have like 5 or 6 issues, I believe. So how about this? Who wants to do the workflow for the linker?
I can.
Yep, that's great.
I can do like the presentation. Like we can go through the slides because kind of the slides give you a motivation for what we are trying to do. Like the API itself is not very interesting. What we are trying to do with the linker is that like the purpose of the linker is to make apps smaller by stripping unused code. And it's kind of well known that it has problems with reflection because it's really hard to find things that are truly unused. And I have an example there where you can just like activate a create instance, a type that you can download the string from the internet. And kind of now for us, it's more important than ever to be able to make apps small because WebAssembly is coming to .NET, and also Xamarin is switching to .NET Core. So kind of that's the problem. And the main problem is really the conflict between a small app and a working app. Like if you enable linker and you don't have a good idea what kind of reflection will be inside, it's very well possible that after linking and removing unused codes, your app stops working because some of the code was actually used. So in .NET Core 3.0, we shipped linker as an opt-in option in a very conservative mode. Kind of the very conservative mode didn't touch user assemblies at all, removed entire framework assemblies if they appeared unused, and kind of it didn't try to remove individual types or methods. We got kind of decent size savings, but they are not great as they could be. And even this very conservative mode managed to break some apps sometimes. So the experience is not great. And kind of we were thinking, can we do it better? So the next slide, you can. So we were starting to think about linker safety. Kind of how can we give guarantees to the customers that a linker will not break their apps? The experience right now is that we asked customers to kind of retest the entire app, but that's really frustrating. And whenever you make a change to your app, you could have accidentally removed something, and then reflection stops working because the reflection was relying on some code path keeping something that is needed. The bad thing about this is really that it's not unit testable, because if you run the linker on a unit test, then basically the linker will think that different parts of the app are used. So kind of it like you really need to automate it somehow. So kind of that's the direction that we took. And if you go to the next slide. We were starting to think about, okay, how do we automate this? And we started with bringing over pieces of reflection analyzer from .NET Native that is able to analyze obvious uses of reflection in code. Kind of if you have something within a method and it's not doing something too complicated, then linker should just figure it out. And it should be able to kind of see through the reflection patterns in there. We also said that whenever analyzer within the linker won't be able to figure things out, it will warn. That's a new thing compared to .NET Native. The warnings were not there because there would be too much noise. We came up with some annotations to help linker analyze things better. And we would also like to come up with suppressions for some of the warnings that could be for things that are actually fine.
Can I ask a quick question here? So when you say warnings, so who will see the warnings? Is the analyzer for our own code, or is the analyzer something that the customer runs?
So it will be possible to run it both on individual assemblies or on the entire app during publishing. So kind of I would like it to be enabled within CoreFX build as well, so that we can see those warnings as well.
And I guess the warnings are basically for you have annotations that are not sufficient.
Yes, like there is either annotation that is not sufficient or just like some crazy reflection use that cannot be reasoned about statically. I will have some examples.
Okay.
Just want to, yeah. So maybe we can go to the next slide. So like these are kind of the easy cases that we are enabling. Like if within the method you have code like this, it should be possible to statically analyze that, oh, we need to keep default constructors, we need to keep an extra method, we need to keep an extra field. So kind of that's something that we will enable so that you don't need to annotate too much, but kind of real world code is almost never like this. So kind of that's why we also need some annotations to kind of help the linker. So we can go to the next slide maybe. So the question was really, what should we do when there is some end-to-end reflection pattern that is not visible within a single method body? And like, how do we make sure that that kind of reflection can still be safe and we can kind of provide actionable warnings? So the thing that we came up with is a way to attach annotations to locations of type system.type within the code base. And that annotation would specify some kind of demand on the value that is being stored into the location, or give it some like extra capability or annotation whenever it's loaded. So kind of you can annotate, let's say, a field or a parameter on a method and say that whenever you store a system type to this location, that system type needs to have all the methods kept, for example, or all the constructors kept, or all the fields kept. And kind of the linker can reason about this, and it can see that, like, for example, you have a type of within the app, and then you store it into a location like this. So you kind of pass it to a method that says, like, whenever you give me a system.type, I need all the constructors. So kind of linker can reason about something like this, and it can kind of make sure that these things happen. So kind of you either need to pass it something that is known. So it's either it comes from type.getType with a known string, or it comes from a type of, or like it comes from some other location that is annotated the right way. And whenever this doesn't happen, it can warn. So maybe next slide. And this is just a really quick example of like how the data flow through many things would look like. So we have a field of type system.type that is annotated with this custom attribute that we are proposing, and the annotation is saying that like these types will always have all the methods kept. And then within the app, we can see that there is a store into this location, and the store is with a known value, because we can see there is a type.getType with that known string. It's something that the linker can reason about. So whenever it sees this kind of store, it will just kind of keep the type, and it will keep all the methods on it. And then we have another location within the program where we load from this field and call some reflection API. And since this location was annotated, we know that this reflection API call is safe. Kind of if the annotation wasn't there, then kind of linker has no idea what is it operating on, whether like the method can be kept or whether it's not kept. So it would issue a warning. But because the location was annotated, it knows that this operation is safe.
So basically, that means now if within the type program, if I now would use other type to access properties of fields or reflection, then that means I did not get my notations correct. Right? Because so basically, the other type field is marked with saying, okay, I will use this type to access methods potentially. So keep all the methods. And if I would now, within the program type, if I would now access properties or fields or events, that means I just got my annotations wrong, right? So now the linker would remove potentially those things, and then I would be screwed, right?
Yes.
But it would give you a warning.
Right, so that's basically what I was getting at. So the idea is that the analyzer would give me then warnings when it sees accesses to other type where I ask for events or fields, because annotations say that I'm not doing that.
Yes. Like those annotations don't guarantee that something else would be kept. Or actually, for properties, it would actually work, because kind of all the methods on the type are also, that includes property accessors, which means we keep also the properties. But yeah, like that's the general idea. Maybe next slide. And then the last part that we would like to think about is warning suppression. So sometimes we know that something is safe and kind of we can guarantee that, but it's not obvious to the linker, and there are, like, we couldn't come up with a good way to annotate it. And that's, for example, if we place an annotated system.type into a list and then we take it out of the list, kind of we know that whatever we put into the list was annotated, so kind of the load should also be resulting in like an annotated value. But the linker will not know that, and it would normally issue a warning that, like, hey, you got system type, I don't know where you got it from, and like you are trying to access methods on it or trying to do something with it, and I cannot guarantee you that those things will work. So kind of for that, we would like to come up with some suppression attribute where you can suppress the specific warning and just say that, like, yeah, this operation is fine. And the last thing is that, like, this of course doesn't work for all reflection, and there are some patterns that are never compatible with linker, and that's kind of like I have code somewhere that is just reading some string from the internet and just like activating a random type. Kind of those will never be safe. Linker will always warn for them, and it would be nice if, for example, a library developer would be able to annotate their API that, like, this specific API is not linker safe. So kind of if you are running a tree shaker, like the IL linker, don't call into this API. And then there could be some kind of message or something that will say that, like, yeah, this is not safe. Like, we have some other API or something that, like, you can use instead, for example.
I have a question on this slide. Does this imply that if I'm a library author and I use these patterns, I additionally have to annotate my module with these attributes, or that the linker can identify these patterns and automatically assume that I have that attribute?
So linker will not do those things for you. You have to annotate it. It's kind of like the nullable annotations in C#. Like when nullable came out, you have to annotate everything manually. Like the compiler will give you all the warnings. It will tell you where you have to put them, but you have to actually do the action of and place those annotations.
So this attribute
actually, let me step in. It's not. Yeah. I think the experience will be slightly different. Like, the experience will be that the linker will see into the library and will find that you're using the pattern there. And if it's not like fixed in the library, like annotated correctly, and it doesn't leak out, then it would say nothing. But if it leaks out through whatever means, or it's not annotated, then you would get a warning. The difference would be that in this case, you would get a warning about some internal methods in the library, so the experience is not great. If you put the attribute on the entry point, you would instead get that, which could have like nice message, which is like domain specific, right?
So just to clarify then, if I have a library that uses one of these patterns and I pull it into my own application, say that the library was created 5-10 years ago, so it's not going to have this attribute. What's the behavior that my application would have when it pulls in such a library?
When you run the linker will issue some warnings from within the library.
Okay, and those. So who's the target audience for this very specific attribute, the library component that's using these patterns?
It's kind of a combination. We need it ourselves because there are certain methods in our reflection which are simply unsafe, like assembly.getTypes. So you'd put it there. But also you can use it on the library to basically say, whatever is behind this API is not linker safe.
Okay.
Please don't call this.
And you anticipate that the number of libraries which are under active development, so people are pushing out new versions in 2020, is high enough to make this attribute worthwhile? Because I clearly can't apply this attribute to an existing already shipped library, because if I don't own the source code to it, I can't recompile.
Yes, and that's not necessarily required. You would still get a warning, it just wouldn't be as nice. Right, so if you put it on if you use it on a code which is not safe, linker will warn. The question is, what will be the message you get?
Sure.
If you don't put any attribute. Sorry, go ahead.
The reason behind these questions is I was trying to figure out who the target audience for applying these attributes was. If the target audience is people who have already shipped libraries, well, we can't ship a new API for them because they've already compiled their code. If the target audience is us internally, does the attribute have to be public, and so on?
I see.
It's a conversation that we can have later.
Yeah.
I just wanted to kind of seed that discussion.
Are we talking about specifically the requires on reference code attribute on the slide, or are you talking about all the attributes?
This slide specifically.
Okay.
I think we need it publicly, but it's for the public usage, it's mostly about like having a better experience with a library, and also like Xamarin or Blazor will use this, or like the higher level frameworks will use this, right? So then the question becomes like, do we keep it sort of internal and internalize it for them as well, or do we make it public?
I mean, we should probably go through the slides before we make any judgment, but the way I understand it is like, if we assume that nullable would be not a C# feature, but nullable would have been an static code analysis feature, then that would be similar to your experience, where you get warnings, but the warnings are now inside of the library rather than at the entry points to said library, right? So basically, the consumers of the library has the worst experience unless the author of the library annotates the entry points. But the feature will also work when the library author didn't annotate the entry points, right? So I guess that's why it needs to be public, because the idea is that library authors holistically buy into this model and annotate the libraries to be linker safe, and then consumers of said library will basically have a better experience.
Yeah, that's the idea.
Okay, that was the end of the slideshow. Okay.
Awesome.
All right. So what is the first attribute we should look at then? This one here, or?
Yeah, like I would probably start with this one. So kind of this is the annotation to put on the system type. We would also like to enable putting it on system.string locations. Like that's not like an API review thing, because you cannot specify what types this attribute should be placed on. But whenever you place it on system.string, the expectation would be that this is a fully qualified type name. And that kind of helps in a bunch of places where people pass around a string and then type to get type that string. It's common enough that it's probably worth it.
So basically the idea is it would generally apply to variables, fields, properties, and so on, of type system.type or system.string.
To both.
Yeah.
Like if it's system.type, then like it's obviously the type that we talk about. If it's system.string, then linker would assume that it's a fully qualified type name. So kind of whenever it sees a string literal, it would interpret it as a fully qualified type name and then do stuff with it.
Right. So then I guess my question to you is, does it mean that when you see system.type, you assume runtime reflection is going on?
So at that point, linker wouldn't assume anything yet. So this is just an annotation that helps at the consumption side whenever you call some reflection API. Because the thing within the linker is that if you already have a system.type instance, then that type by definition wasn't stripped.
Right.
But it doesn't tell you anything about the members of the type, because all the members are eligible for stripping when aggressive modes are enabled.
Right.
And kind of that's why most APIs called on system type are potentially unsafe. Like you can ask for a base type that's safe, but if you ask for a method or a field, we don't know whether you will get back a null or whether it will work.
Right. I guess what I'm getting at is, so we have this thing called metadata load context, where you can instantiate the reflection object model over metadata that you read from a file, which wouldn't be runtime reflection, right? So,
yes,
what would somebody do who has a library that does that? For example, imagine we have a library in our world where it allows us to diff API surfaces, right? So we built this library, and the library, of course, exposes system.types and member infos everywhere, but none of them are runtime reflection. They're all effectively just what what the runtime reads for metadata that was, passed to it. So
yes,
how would somebody annotate that library and say, like, there's no reflection going on here, so don't worry about it?
Yeah, so they would need to use the suppression mechanism, because kind of the linker has no way to distinguish between like the system.type that is the real runtime type or like one of these made up things. Like that's.
And how does the suppression
you can
work?
also not strip, for example. You can choose not to run linker, then you don't have the problem at all.
Right.
Or you have to suppress warnings.
But so how does suppressions then work? Is that done with this attribute as well, or is that a completely different mechanism?
That's a different attribute. I just made the issue for that, so it's probably not on the radar, but
I see.
You should probably include it.
That makes sense.
I will send you the link to that, because it sounds like something that we should review together with this.
And so when I put this attribute on the property and I say, for example, methods, does that mean public and private methods, or does it mean public methods only?
So there is an enum below this, and that specifies what. I tried to match the enum to how binding flags work. So that's the dynamically accessed member kinds enum, the bit field. Did you see?
Yeah, I see the member kinds. I'm trying to make sense of the, you have public methods and you have methods. Does that methods now mean public and private effectively?
Yes. It's basically trying to separate into the two categories, because reflection APIs always have the one simple API call where you just say get method and give it one string, and that one only searches for public. So kind of this is trying to optimize for that and have encoding for the kind of most common reflection API, because then you have the other reflection APIs that take a string and a binding flags, and then you can say, oh, so look for non-private or something, and kind of that's why there is this distinction, so that we can keep fewer things if you are only calling the simpler reflection APIs.
Yeah, I think this is actually backward. Normally on binding flags, you explicitly specify non-public. So the idea is, just take methods, for instance. The idea is if I said methods, I would expect only public methods to qualify. If I said non-public methods, then I would also expect private, protected, and internal to qualify. So my feedback there would be to flip what those flags mean, actually. And to have methods and non-public methods, as opposed to methods and private methods, because non-public is a wider net to catch.
Does methods kind of make it sound like all methods, though?
Including property getters and setters?
Well, just if you just say methods, doesn't it just kind of feel like all methods? Like, why does that implicitly imply public methods?
Yeah, I mean, this goes back to what Levi earlier said, right? It's the reflection default, right? If you say reflection, get method, for example, and you pass it a name of a private method, it would not tell you anything unless you use the longer overload where you can pass in binding flags and also opt in for private state. I think in general, like, people don't think of private state by default, right? Because if I reflect over something, then, it's reasonable that I start with public API surface, right?
The reason for that is the target audience for reflection is I need to call this API, but I don't necessarily know what the type is at compile time, so it's a runtime check. But private methods, by definition, are implementation details that the type author did not intend to expose to arbitrary callers. That's why in the reflection surface we explicitly make you pass in a flag saying non-public. Like I intend on calling an implementation detail. Please don't stop me. Like serializers, for instance. Most serializers would never call implementation details. They only care about public reflection.
Okay.
Yeah, and if you were just using reflection for a forward reference into an assembly, you wouldn't want the linker to keep all private members around. You'd want it to be able to still tree shake them based on they were just an assert method.
For sure, we need the two different ones. I'm just saying, if you just say methods, does it feel like that means all methods?
Well, from a linker perspective, it's going to be everything anyway, right?
Not because if you flip what you just said.
No. So if I'm telling the linker I want all public methods to stay there, presumably all the private methods would come along for the ride too. Because why does a private method not exist if it's not being called by one of the public APIs?
If it was flagged with conditional debug, it's still there in the release build. But if nothing ever called it, then it would be dropped out by the linker.
Okay.
Kind of the point that I was driving towards is specifically the naming part, right? You said if I tell the linker to save all public methods, it's like, well, no, really what you're telling the linker is save methods. And that implies public methods. Right? Like it just feels, to me, it just feels a little bit of a trick to just say methods, and it doesn't mean all methods. It only means public methods.
Yes, but this would be surprising to someone who uses the reflection APIs, I think.
Yeah, I think
we just specify the visibility on all of them, just have public methods and non-public methods?
Or all methods, public methods.
I think a good example is that if you call type.getMethods, it would map to public methods in this enum.
Right.
So that's kind of the counterintuitive part, right?
Yeah, but at the same time, it's also a little counterintuitive that type.getMethods only returns a subset.
I agree.
No, I disagree with that statement. Like it's the point of using reflection in that capacity is to call something that you normally would have been able to call, but you don't necessarily know what it is until runtime.
Says who?
That's how we've traditionally used reflection. Like look through the framework, look through callers. It's very rare. It's very rare to call an implementation detail of a method unless you also own the implementation type.
That's fine, but that doesn't change the fact that if I ask you how many methods are on this type and you only tell me about a subset of them, that's very strange.
But you didn't ask how many methods are on the type. You asked what methods are accessible for me to call.
No. If I just say type.getMethods, I didn't say anything about what's accessible. It's the fact that we implicitly imbued that with an opinion to only return a subset of them.
Sure. Should it also return the finalizer? Should it return the constructor? Like it's not returning all methods.
Also strange.
Yeah, I mean the point was not the historical precedence; it's the intuitiveness. Yeah. I think that's what Steve's commenting on.
But I don't know. I agree with Levi. Is that the thing is reflection has a use case, right? And I think the vast majority of people don't reason about private state.
What is the downside to including the visibility on all the things here? Like having public fields and non-public fields, public methods and non-public methods, rather than methods and non-public methods?
I don't have any problems with that.
No, that one seems fine. Like I would just say we should not have methods meaning all, because that means the vast majority of people will use methods and then effectively pin private state, which they probably didn't intend.
So Steve, are you saying we should split it so one isn't a superset of the other one? Like the way it works today.
I joined late. I apologize, but I'm just looking at what's on the screen right now, and there's methods and public methods, and I'm suggesting that yes, they are non-overlapping. So there are public methods and non-public methods, and if you want both, you specify public methods or non-public methods. Just like in reflection today, if you want both instance and static, you specify instance or static.
Or public and non-public, you have to put public.
Right.
On non-public. that would definitely more align it with how we're doing reflection, I guess.
I mean, binding flags is not necessarily a great API.
No.
But yeah, I mean, I would agree with you that it aligns it more. I mean, I'm personally fine with public methods and private methods. I'm also fine with saying you just have methods and then there's public and private as different flags. That also works.
Yeah, my feedback on that would be use the term non-public instead of private, because non-public implies more than just private.
Yeah, I mean arguably it's the same.
Tricky cause...
Yeah, public also means protected, right? But yeah.
Yes.
Really, you want?
No, actually, no, it doesn't.
Okay.
Public.
I guess really what you want is public, externally visible, and non-externally visible. But we don't use the term externally visible in reflection.
Yeah, I would probably still stick with the binding flag terminology, which is basically there's public and non-public, right? And public means protected as well in binding flags land.
It doesn't. The public does not imply protected in binding flags land. Instead, what happens is, if you, from a linker perspective, if you're keeping public methods and one of them would tree shake such that a protected method happens to remain around, then yes, you can call that. But public means quite literally public and only public in reflection land.
Are you 100% sure?
So we should do it with the same semantics.
Yeah.
Whatever those semantics are.
Yeah, I'm very sure that public means public and only public.
Yes, it does. We tested it recently. And it's just a note on properties and events. It's a bit weird. But what public means is one of the accessors is public.
Right.
Not necessarily both.
So is the consensus then, instead of having methods, we have basically public methods and non-public methods? Is that fair?
And then we have to change the values as well.
Yeah.
Yeah.
Non-public methods wouldn't get the public methods bit flipped.
Basically align it with binding flags, right?
Right. I'm fine with that. If we're voting, I guess.
Yeah, what I'm trying to figure out is what the behavior would be if someone passed in non-public and didn't pass in public as a flag to this API.
It would mean exactly what you think it would mean, right? All the non-public ones are preserved, and any non-called public ones could get trimmed.
Yeah.
I mean, if you're going to reflect, jump past a public method, then it doesn't need it anymore.
If you cared about that scenario, you probably care about keeping only one or two very specific methods around, to be perfectly honest. And if there was a way to do that, which I think per the slides there was, then I would probably honestly use that attribute instead of this one.
So the specific methods, you cannot annotate it with this kind of flow semantic that you can flow the type through the system and pass it around. And then by the time you try to call the get method on it, the linker would know that, like, oh, this one specific method was kept. Like we don't have a way to express that. So kind of if you just want one specific method, you either have to do all of the reflection within a single method body so that the linker can see it. You know, if the linker can see that, like, oh, that there was a type of, and then you call on it, this one specific method and you are looking for that, then it will keep that one specific method. But if you want to kind of pass it around, then kind of I don't think there is a good way how to annotate things like that.
If you knew the specific type and method, you could use preserve dependency, which I don't know if we're reviewing it here, but it's another proposal. I think it was on the email.
Yes, but that one doesn't have the warning part and the safety part. So kind of I try to keep it as a separate thing. It will be reviewed today, hopefully, if we get to it.
Yeah, it's the third one in the tabs right now.
Right, and that one's more static. It's this type, this method, where this one, it's like the type can be a bunch of different types dynamically. But it does kind of bring a question, like we're putting a pretty large, we're casting a pretty large net, right? Like I need one method, one public method, but I can only say all public methods, right? Are we okay with not making it more granular than this?
If I were consuming something like this, I would want the ability to specify granular, but I don't know if I would use this attribute for it. I would use a different attribute most likely.
Yeah, I think it depends on what you're writing, right? If you write a serializer, for example, you would just say public properties and you literally don't care which ones, right? Anything is permissible because you don't care about specifics, you just match them based on input. I guess methods is different because methods, you clearly have to have a knowledge what you have to pass in for those guys, right? So there's probably an expectation that you find specific methods. You may not know whether the method exists, you may do pattern matching or something, but you probably know that you're looking for particular names X, Y, and Z with a particular set of parameters, right?
Yeah, an example of that would be like a plugin framework model. Like I'm looking for a very particular entry point to this type, and then once I find it, shake out everything I don't care about.
Well, like serializable, right? Like the get serialization info.
Yes, that's a good example.
Like from the enumeration that is here, the dynamically accessed member kinds, I think the most valuables are the constructor related ones and the field and property related ones.
Right.
Because constructors is like that's the major thing that people do with reflection. Like they will activate the clear instance something that came from somewhere else. So kind of that's the highest value that I see. And then kind of fields and properties, it's like, yeah, if you are doing data mining or like you are doing something and just like want to dump everything that is on the type. The rest are there for parity or completeness.
I mean, I will say though, I think it's convenient to have an attribute that allows you to keep almost everything if you needed to, because that probably helps in debugging quite a bit. If you can just say, you know what, let me just annotate this particular parameter here and then see what happens. And then if that works, maybe then you go down the path of finding more specific annotations.
Also, the other consideration is that like having more specific annotations, the only advantage is that you get smaller app, right? It's not about correctness anymore. And so the question then is like, how often is it that if I pick one specific method out of this 20 which are on the type, how much of a size when will that get me, right?
I mean, that's the problem with graphs, right? I mean, all you need is one edge to potentially root a bunch of other stuff, right? So it's hard to say in general, I guess.
Yes, I agree. But I think my point of view on this is about correctness. Size comes second. And so if we get something which is reasonable size, but it's correct, that's a win. And then we can start reasoning about, okay, can we make it smaller? Maybe there are better ways to do that. But
yeah. I mean, that's certainly something we learned early on in the .NET native land, that having apps that work, it's better than having apps that are small.
I had a quick question on this. Another question. If a type or a method does stick around, the linker doesn't shake it out, do all of the attributes on that API come along as well? So I could use reflection to access that data?
That's a very complicated question, but the default mode, yes, it will keep all the attributes. Okay. There is a discussion now that, like, especially with nullable, keeping those attributes has non-significant size cost, and it's probably never used at runtime. So, you know, those kind of attributes which are like, we don't really need to keep them around. So there's a discussion to maybe have a mode to get rid of those. And then there's a very aggressive linker mode, which is opt-in, which can try to remove attributes, but that's very problematic right now.
Got it. So
it typically trims more than it should. So.
No, that makes sense. The context behind that was if I'm using reflection to get a method info back, can I do more than just invoke it? Can I otherwise inspect it? It sounds like the answer is by default yes, even with this.
Yes, yes, that's the expectation. Also, similar for properties. If you mark a property, if you access property through reflection, we will bring all the accessors. Even though linker itself for like statically referenced things will differentiate between getters and setters. But the reflection will always pull everything because we don't know what's going to be used, right?
Yeah.
I look forward to what happens when the linker prunes away the object finalizer.
Yeah.
I mean, the attribute one is a good one because we just had the same discussion with the version attribute we want to put in the iOS and Android SDKs, and they are literally on every single API, so they will be very, very noisy. And size-wise, probably not great.
So there's a discussion going on that one of the proposals is that we would have a list of the known ones which we should trim because we don't expect them to be used at runtime and they are used a lot, right?
Yeah, we can. That's actually a very reasonable thing. I mean, ideally, we can also mark the attributes themselves with an attribute. That basically tells you
that, yes.
And because probably it's a function of the attribute, right? It's probably not a function of the use side.
Agreed.
All right. So then, any other concerns with the APIs proposed here?
Ship it.
Oopsie. Problem with too many windows. All right, then I will copy and paste my notes down there, and then this is it.
The enum's going to be an int, right? So we have 32 of these to add.
Yeah, generally enums are ints, yeah.
Yes.
Although, what would you add more than the ones you have here already?
There is actually a possibility that we would add more. Like interfaces is another one, and potentially
recursion,
something like recursive properties for serializers. It's being discussed right now. We don't have an agreement on that.
Along those lines, does it make sense to have an all, which is just basically the -1 value for this enum?
Yeah, maybe. As I said, like we're starting with using this, so as we use it in the framework, we'll probably run into cases which will make it easier to reason about.
I'd be careful with all if they're unused bits because all will then mean different things across different versions.
I mean, you could define it now as basically all ones, right?
Right, but if you built something in 5 with all and then build it again in 6 with all, but we defined 2 new bits, it has all means everything that we still knew about, but it will behave differently.
The question would be is if you explicitly set everything that's on here today, is there anything the linker would be able to trim out today that if you added something else in the future, it would no longer mean the same thing? And I don't know the answer to that. Presumably the answer is no, because if that was true, we would already see more things here.
I think the answer is no, but we would have to double check. But
the hesitance there is why I would not add the all.
But even then, we're not talking behavioral differences, though, right? Like, ideally, if I said all, I shouldn't see any runtime behavioral difference between 5 and 6, even if potentially the size on disk is changed.
Yeah, hopefully.
Maybe.
And we could also do it such that if it's all, then we will check for it not bitwise, but for the value, and like literally keep the whole thing, regardless of what the bit field says, right? So then all would always mean all, regardless of version.
That's reasonable.
Yeah, would none make any sense? Probably not, right? In which case you could probably use 0 as the placeholder.
Well, you wouldn't define this attribute anyway if you passed in none.
Yeah, it's as if you don't put it there. So
yeah, we should. I guess that's a good point. We should add the word none with no bit set because we always name the 0 value, and for bit fields it's always called none.
Okay. Yeah, I guess a scenario for that would be if you want to compare the value against none and then take some action, but you would never declare this attribute and then pass in 0. I would assume that would be a meaningless thing to do.
yes, it's meaningless.
Right, but it's if you toString something that was cast to this, it'll print 0 instead of none, and then
Sure,
people
yeah.
get tiny, and yeah.
Yeah, that makes sense.
Yeah, we kind of did.
So add none, don't add all. Is that the decision?
Adding all is reasonable if all just says this type is preserved and the linker is not going to inspect it further, because then no matter what changes happen in the future, it will still have that behavior.
Right.
My concern is just if the behavior becomes measurably different in the future, then now there's a compatibility question, and we like compatibility, so we spend a lot of time debating what it means. So
yeah, and that's a good point, but I would assume that a behavioral change there would actually be a bug that we would address instead of an intentional change. At least that's my assumption, because I don't see how on earth all could mean anything other than don't shake anything whatsoever off of this type.
Well, the recursion is kind of a thing, right? Like if we added that in B6 to mean this type plus any type it references, right? Like a graph.
Well, presumably yes, because if A references B and I said keep A around, presumably B should be around as well, right?
It'll be
is,
around,
but
but its
members,
methods, right?
The recursive properties idea is that it would recursively keep properties on the reference types as well.
I see. Okay.
Oh, meaning that the same settings that you've selected in this attribute would be applied to anything that it in turn referenced?
Right.
Yes.
Interesting.
The idea being like a serializer case where
Yeah,
I'm serializing foo,
but
and
we could model that as a separate parameter to the attribute, right? It doesn't have to be in the bit field, so that the all wouldn't be broken by that.
That's true. Good point.
And in fact, it feels like that would be cleaner because that's not really a member kind.
True.
I would agree with that too, yeah.
Can this be multiple? Can the attribute be applied multiple times on one?
No, it shouldn't. It should be one time only.
I never remember what the
Yeah,
default
we should
is.
also.
I can't remember the default is either.
Why is that the case? Like, couldn't I have a derived type that wanted to keep additional stuff around?
So this doesn't apply to types. This only applies to places where we store values. So
Okay, what about
and there is a separate rule about like virtuals and overrides where we'll try to force people to keep the whole tree the same, because if it's not, then the linker has real hard problem reasoning about things.
So what does it mean for derived then? You're basically saying when you apply it on a virtual member, it will implicitly apply it to every derived type, and they shouldn't be able to redeclare it.
I think the linker current plan is that the linker would warn that you have to annotate the derived ones as well with the same value.
Okay, so that means the attribute would be marked as I'm not inherited, and so I cannot be inherited and I cannot be applied more than once.
Yes, I think that's true.
Yeah.
Sorry, I missed the beginning, so I missed the context. But what does this actually end up signaling to the linker?
So on the consumption side, when you read a value which is annotated like this, it makes a guarantee to the linker that, hey, this thing has all methods, and so if you call .get method, it will work and it won't warn. If it's not there, the linker would issue a warning saying this .get method is dangerous and we can't guarantee that it's going to survive the trimming.
Sorry, what's a concrete example?
Can you pull the slides up, Emo?
Yeah.
You missed the slide, Steve.
Yeah, sorry. I had to do the question, and I just want to make sure it's not stupid.
Actually,
not that one.
Yeah. The next one. Yeah, this one. So the last line there, that's what where the potential problem exists, because linker doesn't necessarily know what the type is, what the other type is, right? So if it's not annotated.
This is only applicable to fields and properties of type.
Yes, and string, and then it assumes it is a fully qualified type name, and you use it with like type.getType.
I see. Okay.
Carry it over.
Yeah. Can you go back to the API then?
Just to clarify, like we can't within the runtime say this attribute is applicable only to fields of type, or string. That would have to be some analyzer or something that was making that claim.
Yes. The linker will ignore it everywhere else right now. So you could also make it fail if that's the desire.
Sorry, I was muted. I was saying you should probably warn, because probably clearly somebody fucked up when they applied to something else, right? They thought it would mean something that it doesn't.
Okay, we can do that.
Yeah, my point was just that if you did want that warning, failure, whatever, that would have to be from some group external to API review. That's all.
Are we planning on analyzers for this? Like that's not the linker, but like a Roslyn analyzer?
Yeah, one day, hopefully.
Okay.
I mean, in the beginning you talked about warnings. What would those warnings be? Wouldn't they be Roslyn analyzers?
No, they would come from the linker. So like whenever the linker tool runs.
I see.
Yeah, it really just ends up being a question of how soon do you get the warning? Do you want it as you're writing the code, or do you want it only when you run the tool?
Well, when you're a third party, right, you might never run the tool. You ship your library with bad annotations, and then it's your users that would get the warning.
Sure. At the same time, though, there are a lot more things, presumably, that those annotations could be, many more reasons those annotations could be valid, and if they're not being tested, I don't know that analyzers could, unless the analyzers fully subsumed the functionality of the linker, I'm not sure you could get to 100% coverage.
That's why it's hard to write an analyzer, because currently the way the linker works, it assumes global knowledge, and analyzers are by definition local. So there might be ways to do it, but it's not necessarily easy.
I mean,
In other words, I agree. I was just gonna say, I agree, Eric. Analyzers would be valuable for like the library author, but at the same time, I think the library author is still going to need to test.
Oh yeah, for sure, for sure.
Yeah, it would just be to make it slightly earlier, right? I mean, use side violations, like you put it on something that isn't system string or string, makes sense because you can actually make that a local decision. But everything else, yeah, you have to test it for reals.
Yeah, if you're cognizant enough to put these attributes on your class, probably you're going to test it as well, or you should test it as well.
I mean, the testing is actually simple. It's literally running the linker on it. You don't have to run code. That's kind of the whole promise of this feature, that we will tell you statically. You don't have to run the code.
Well, yeah, except that you the only way to find out that you have missing annotations is by actually running the code, right?
Well, not really, because the linker will, like if you run it on a library which uses reflection and no annotations, it will probably issue many warnings because any reflection call will be marked as wrong, right?
Oh, I see. And how good is your detection for if I said methods, but I actually asked for fields? Is that 100% bulletproof, or are there cases where you?
Yes, it is 100. Yes, it is 100% bulletproof. Well, unless we have bugs, obviously, but the goal is that yes, this is 100%.
Oh, awesome. All right, so then let's close this one here. So we approved it. My notes are at the bottom here, in case anybody cares. All the bullet points we talked about. Is this the next one then?
Yes, but this one might be more controversial. So if we can look at the suppression instead. sent the link into the chat.
Let me dig it out.
35339.
Eventually, I will be able to copy this link.
Did we already discuss the namespaces being used here?
We did not. I kind of looked at it and thought that seems reasonable.
Yeah, I'm just wondering how we're thinking about things like these versus, like, we put all the nullable annotations in system diagnostics code analysis. I don't have a strong opinion, but I'm wondering if you feel that.
No, you're
better.
totally right. Compiler service is meant for things that the user doesn't usually do themselves. This one seems more in alignment with the nullable attributes that we want people to actually manually specify, so they should probably be in the other namespace. Jeremy, what do you think?
I agree with that assessment. Put it with nullable, not with compiler services.
If there's going to be a large number of these attributes coming through, does it make sense to carve out a sub-linker namespace for it, or is it not worthwhile to do that?
Well, one of the main feedback in previous discussions was that these shouldn't be linker specific, or the naming shouldn't like imply linker in most cases.
Sure.
The suppression one is special because it's like a specific tool, but the ones which are describing the code should be about the code and not about the tooling. Michal, do you want to talk about this one?
Yeah, sure. So the naming for this, yeah, this is the name that we came up with, but it might not be the best name. The purpose of the attribute is very similar to the existing suppress message attribute. So we were thinking that, hey, maybe we can use suppress message attribute because it's very similar to when you are getting a diagnostic, for example, from a Roslyn analyzer, and you know that the diagnostic is not applicable. And in the linker case, it's basically you have reflection that linker cannot reason about, but you are 100% sure that it's covered by something else somewhere. And kind of the issue that linker thinks could be at runtime actually will never happen. So kind of this provides a way how to suppress it. And I basically just took as an inspiration the existing suppress message attribute, and I removed, I think, 2 things from it, and this is the result. And the purpose is really to suppress message potentially from any tool that runs after linker, kind of or after the C# compilation, which is why maybe suppress linker warning is not a great warning, because we could potentially make it more general purpose. But the problem with suppress message attribute is that the attribute is conditional and it's not usually generated into the IL. So it's not useful for tools that run after kind of Roslyn is done.
Is there
Why wouldn't this be sorry, go ahead.
I was going to ask, is there another compilation constant that we would expect to be set? We could always update suppress warning, or suppress message rather, with an additional conditional.
So the thing is that the linker will normally run on kind of the final release build of your app, and I don't know if we want to keep the code analysis things or all of them. Like we need a subset, but not all.
For example, these attributes, if they are in the framework, would have to ship with the final release bits of the framework.
Sorry, I didn't quite follow. What I was suggesting, and maybe it doesn't make sense, but right now, suppress message has a conditional code analysis on it. If we added another conditional foo on it, then it would remain in a compiled binary that had either foo or code analysis set.
But then we would have to put foo for everybody who's compiling libraries and us and their
using
app.
this attribute.
Yes.
Yes.
Yeah. Right.
And like there are probably already places in the framework where we would like to use it. And that means we would have to ship framework with the foo defined.
Yes.
Can we give some examples on like when the linker couldn't figure it out, but we are 100% sure it's safe? Maybe just one example, maybe two.
Michael had an example in the slide section.
Yeah. So the example from the slides was when you take a system type and put it into a list, or you put it into a dictionary.
Oh, right.
It wasn't a code example, it was just kind of written example, so not so useful in the slides.
Yep, I remember that one now.
But
I remember another example was when we're comparing two structs and we're looping over all the fields. And if the field is trimmed out, you might as well not have to compare it because it's not there. So it's safe. It's safe to get all the fields on a struct and compare it with another one. Right? That was another case where we'd want to use this.
Yeah,
that's the internal usage. Like there are actually many places in like corelib specifically where we do things which are always safe, but from this analysis point of view are unsafe. But I don't want to like, that's noise for this discussion, right? That's internal implementation details of reflection. For normal users, the case would be just the one which Michael described, for example. Or anything which, like, when you cast it through a non-type variable. So, like, if you store something in an array of object, then the linker will lose track of it, right? Arrays are a good example in general. Collections, specifically about arrays, are especially like bad because there's the linker can do very little to trace it through the array.
Yeah, just today I was looking at the CS WinRT, the code generator for kind of the new way of doing WinRT interop, and that one uses reflection, and it has some kind of dictionary of the projections, and that's exactly a use case for this thing, because they place something in a dictionary, and when they are placing it into the dictionary, it can have the right annotation, and we kind of keep the default constructor because this needs default constructor as well. And once we are taking it out of the dictionary, it doesn't have the annotation anymore, but we know that because the dictionary is controlled by us, that everything will have the default constructor. So we can just tell linker that, like, hey, yeah, I'm doing activator.crib instance with this thing. It wasn't annotated, but it's fine because I know it's fine.
Steve, I have a related question for you. Since you've been doing a lot of the analyzers work lately, how do we feel about having suppress message versus pragma warning disable?
I just want to add that pragma warning disable is not viable because it doesn't survive compiler, and so linker won't see it.
So the idea is this as a library, I put this on my library, and then the consumer needs to be able to see this attribute?
So the linker works on all the IL in the app.
Oh, yes, it doesn't see pragmas. Got it.
If we were to do something like this, I mean, based on the description earlier and on the screen, I mean, it really seems like the sole difference between this and the existing one is that the existing one has a conditional attribute on it, rather than this being linker specific. It's just, do you or do you not want it to go away based on what the code analysis is set? If that's true, from a naming perspective, it seems like that's the key difference, unconditional suppress message or some other better name that I just came up with.
Yeah, persisted's the other name that was floating in my head.
Yeah.
I agree. The name we suggested is just a working prototype.
And if we were to do that, I don't know if there's any benefit, but we could consider like inserting it somehow into the hierarchy here. So you had if we were designing this from scratch, we might have, for example, had attribute and then deriving from that the unconditional suppressed one, and then deriving from that like the suppressed one that has a conditional flag on it or something like that. I don't know if we could somehow shim it in here in a non-breaking way, but we might look at that too.
I think we could add it as a intermediate base class without breaking anything.
You'd have to move everything down to it.
That's fine.
It could look identical to the one we already have. That's not a problem.
Right. No, I'm just thinking of, what's the cleanest?
Yeah, I understand.
It just means we have to name the base funky.
If we named it persisted or unconditional or something else, suppress message, we might need to put new on all of the delegating members on the existing suppress message. So like its category would defer to the base category.
Maybe it just makes sense as a separate one.
Fair enough.
I don't think you need to do this because in IL it's always safe to call to the derived one. You don't have to redeclare them. You can just literally move them down. We've done this in the past.
Fair enough.
The thing though is like, all I'm saying is that you would have to define a new type that is the base, right? And that one probably has to have like suppress message attribute base or something, right? Because the generic name is already taken.
I'm kind of going, I'm just thinking about it. The fact though that the conditional one would derive from the unconditional one is a little strange, because then if you just did a type check, is this unconditional? Yes.
Oh, you're suggesting the other way around. Well, I guess.
No, neither way makes sense, because I think the conditional would end up being inherited, right?
Well, if we did it the other way, we took suppress message and left it as is, but presumably it's sealed and we need to unseal it. And then we said an unconditional suppress message extends conditional. The problem we would have with that is if we were still servicing fxcop, we would need to teach fxcop that there's another derived type it should care about. But then the is test makes sense. An unconditional suppress message attribute is a suppress message attribute.
Right.
And so,
but I think you're correct that like none of the tools actually do type checks as in the is test. They typically check for names because they don't have the type loaded, right?
Yeah, I don't think it does anything for the analysis, right? It only helps the documentation. Like generally speaking, attributes, like unless you really want to instantiate the attribute, like polymorphism doesn't tend to help you, because you generally tend to look at the metadata itself, in which case you need to look at the specific names or types, right?
Right.
But it does help the docs. I mean, if we did this for nullable, to just be able to group them all in some sensible fashion, right?
So I think it would make sense, and then it would be up to tools to decide that they want to check for suppress message or unconditional suppress message. And I don't know how many tools we have that are actually using suppress message now, because the Roslyn analyzers are looking at the source code. They're not looking at the output IL. It was only that was only invented because fxcop and the linker are running on post compile. So,
I mean, it just means that the whatever suppression mechanism exists in Roslyn, for example, they would just have to special case this other attribute as well.
Totally left field, and probably the answer is no, but would it be feasible to just remove the conditional attribute from suppress message and say, if you actually want this stripped out, use the linker?
You might be underestimating how much space that wastes, because there's a lot of strings, right, with justifications and other things. And my gut feel is that people would be probably upset if you ship their justifications to their customers.
Yeah, fair enough.
Yeah, especially people coming from framework where they were using fxcop and they just have a process they've been using for years, and then they switch to core and find out, oh, we don't. The attribute isn't conditional anymore. It's now always included in your release output. So.
I mean, I don't think there's many static analysis tools that have to look at the attributes. So I think adding a new one and just teaching everybody about it seems very doable to me. Especially because we can just start with saying, yeah, the only party that honors it is the linker, and everybody else just hasn't done it yet.
Yeah, I mean, the question just comes back to, do we make this extend the current one because that makes us feel good, or do we just make it a sibling that looks exactly like it because that's how all the tools are going to treat it? And I don't have a super strong opinion.
I mean, paging will be did for nullable.
Can we actually extend the existing one because it's conditional? I don't know how the rules work there. Like if like if the base class is conditional, does it mean that the derived class is also conditional?
I guess that depends on conditional itself, right?
I think it's only on the per target, so it would just be that the constructor is conditional, but it can't remove it without. I think it would only apply to the attribute usage and not the attribute constructor chaining. So
I see.
So as long as it's a new type, it shouldn't, unless it itself is marked inherited, in which case we'd have a problem, but I don't think it is.
It's not inherited, no.
So can we agree on a name, at least?
I mean, paging in what we did for nullable, our conclusion was because code analysis is such a small namespace, we did not include a base type. I'm actually fine with making this just appear to suppress message. But I like Steven's suggestion of saying, let's not put in linker in here, just model the actual distinction that it has, which is unconditional. So unconditional suppress message attribute seems fine to me.
Sounds
right,
good.
The other stated name was persisted. Does anyone prefer persisted? I'm only asking devil's advocate. I don't actually have an opinion.
I think unconditional probably reads better.
All right. Unconditional it is.
Yeah, for persisted, I'm mulling that over. It sounds like the opposite of ephemeral, and I'm just having trouble justifying to myself what that means.
It means I say the word persisted a lot in my day-to-day job.
I believe that.
And just to make it clear, eventually we think we should teach Rosalind to recognize the new one as well.
Right.
Yeah.
And Steve did a test instead of a code inspection and says that conditional is inherited through attribute extension. So let's just make it a sibling.
Yeah, attribute usage is inherited as defaults to true. And it doesn't have it on its doc, so it's defaulted to true. If we make this a separate type, do we want to have an interface so people can code against both?
Again, nobody codes against the attribute. The tools look at it as through sort of a reflection lens.
Okay.
Like very rarely you actually see an instance of this thing anywhere.
Yeah,
because all the tools do the tools do string matches, right? And they don't actually load the type. So.
When you final trim the application, is this going to be another one of those attributes that we would put on the list to strip out because you don't need it anymore?
For applications, I think that's a good candidate. Yes. For libraries, the answer is obviously no.
Yeah.
For applications, yes, we should probably trim it. Just like the dynamical access one, the previous one, same story.
Right. Right, because nobody's going to use it at runtime.
Yeah.
All right, so
don't forget to change the namespace, Emo.
yes, that's it should be in System diagnostics.
And would we want to add back the two properties that I removed compared to the original suppress message attribute?
Yeah, I would literally have it exactly as suppress message attribute.
Mm-hmm.
Just maybe one more thought on the name. Wouldn't it be better to call it suppress message unconditionally to kind of make the discoverability better?
I mean, we used to do that in APIs. My care level has dropped significantly because Roslyn effectively in IntelliSense does prefix and suffix search. So if you just press suppress linker warning, so if you just say suppress message, the IntelliSense will show you both suppress message and unconditional suppress message. And it's highlighted so that you see where the common term is, so people will find both of them. So I mean, prefixes might be better for sorting, but as far as IntelliSense goes, it doesn't matter that much. I also don't have strong opinions. If somebody feels strongly that it should be a suffix, I can totally live with that.
I don't care about prefix versus suffix, but regardless, we would use unconditional instead of unconditionally. We tend to use adjectives rather than adverbs in our API names.
Yeah, as a suffix, it would be weird though, right? Like adjectives at the end sound weird.
You've been looking at the intrinsic stuff coming along.
Oh yeah, but they're also not going into the whole of great API name, right?
Yeah.
But there's nothing we can do about somebody knows, oh, I want to suppress this. They start typing suppress, and then they're like, suppress message. That sounds like the right one. They hit that one and then build, and they still get the warning, right? Or link and still get the warning. Like there's kind of nothing we can do because suppress message is already taken the good name. Right? Then they just search linker suppress message not working. It's like, oh, you should use unconditional suppress message. Kind of have to live with that, right?
Yeah, that one, I mean, yes, but that's true regardless, right? I mean, if people use the wrong attribute, they use the wrong attribute.
Yeah,
the linker message, like the error produced by the linker, could have the sample of what to apply, right?
True. Every time, but true.
I have a feeling even if we had suppress linker warning attribute, you would run into the same problem because people would just have suppress message, because that's just kind of muscle memory for everyone.
Yeah. You're only going to hit this once.
And even though we say that, you're right. It is important to optimize for the very first time I hit it. I need to very quickly unblock myself. But yeah.
Maybe it is a good idea for the linker to say, if you feel, if you're sure, you can add this attribute.
Or if there's like an FW link to somewhere, it could be like the first paragraph in the FW link or something like that. We've done that for a few other things too.
In general, I think we will need the links because the explanation is typically pretty complicated and it doesn't fit into a single message. So we should have room in the docs to do this, and the warning should probably have a link in it.
Yeah, I mean, in general, like also for attributes, you can't localize it, right? So depending on how you surface those.
Yeah, that's also true. No, I mean, this is also like, when the linker creates the generic message that it saw this attribute, right? It would probably have a link in it already.
I see. All right, any other concerns, or is that it? Then we can move on. So,
Should we do preserve dependency first?
So, yes, we probably should. Depending on what's easier. I mean, they both look. But I think the argument was that this one was more controversial.
I think preserve dependency is more understandable. Like, there's not as much explanation as needed.
Yeah, I think we already use it in our framework to some extent.
Yep.
Yeah, it's just internal, so the proposal here is to make it public and come up with a better name.
I really wish we had infoof, because that would make stuff like this a little bit nicer, in my opinion.
Oh, for sure.
Like I feel kind of bad that we're introducing new APIs like this that have a wart because we don't have info of as a proper token.
You wouldn't be able to use info for custom attribute because there is no metadata encoding. Only a couple types can be encoded in custom attribute blobs.
Yeah.
Oh, I thought metadata tokens could as well. Never mind.
Also, some of these are actually preserving things that you aren't even in your compilation assembly.
I mean, you could imagine like something like name of, right? Where it just gives you the string as a C# feature. But I mean,
I guess you could.
In general, if the compiler can see it, then you don't need this attribute.
well, that might also be true, yes.
In fact, you shouldn't use the attribute if the compilers can see it, because it has actually better behavior than the attribute.
But the only way you know is if you test it, right? If the compiler can see it.
Oh, like it's either in your reference closure or not, right? I don't see a.
I mean, like if I have some code that's using reflection to call some method, and then I run the linker on it, I need to like go look, did that method still stay here or not, right? Or actually run my app and see if it still works.
Yeah, but when you're compiling the code, you either have the target type in your reference closure. If it's there, then you should take a strong reference to it.
Oh, I thought
because
you meant
like runtime is lazy, right? So like none of the dynamic loading will get you much in terms of like lazy loading or anything. The strong reference is pretty much almost always better.
I got it. I thought you meant either use preserve dependency attribute, but don't use the preserve dependency attribute if the linker can figure it out itself.
Yeah, that's also true. That in most cases linker will figure it out, but
so
if it's like a simple, type get type, so.
What is the encoding that you use for signatures? Like, I assume types are fully qualified, right? And it's kind of what you would see in C# syntax, right? I mean, that's the problem that we have, that it's not straightforward. And like, for example, what do you do with generics? Do you do angle brackets, or do you have the reflection encoding that involves some crazy gymnastics?
So for one, I don't think generics work well today. That's something we should probably fix. And type names are simple. They're just like fully qualified type name, including assemblies and member signature. I don't remember. Maybe Marek would know what is exactly the syntax. Like the simple stuff looks normal, but like the more complicated things, I don't remember.
Yeah, and that's the problem that whenever you have things like this, is like you run it and then it doesn't match anything, and then just nothing happens. So at least you should give people an error or a warning when they refer to things that you can't find, because I'm pretty sure people will make mistakes where they typed the signature wrong, they misplaced a comma, or they added a space somewhere, or whatever the case might be, right?
Yeah, I think it already warns. If it cannot find a target, you will get a message. So. But I'll make a note to double check.
How does the first overload work here? If you just say, I want to preserve toString. On what type and what's assembly? Like, don't you always need the third attribute or the third overload? Or is it assumed to be the type in the current type that you're on?
Yes, it assumes it's current type.
Okay, and then same for assembly. It would be this type. The
Yes.
second one would be this type in the current assembly. Okay.
Sure. I was about to ask.
I think what is important to, like, Marek should probably talk about this some more, but like the use case for this is not just the simple reflection stuff, but it's cases where the dependency comes from non-managed code.
Yeah. So basically the second common scenario is, for example, you do runtime call, right, in your class, in your method, and then this runtime call calls back into your same class, right? So you want to keep dependency inside your class, and you don't have a strong link, just use that.
I see.
Makes sense. Is there any reason?
You can only.
Sorry, go ahead.
It says you can only put it on methods, constructors, and fields. Like in that case, you'd put it on the first method that calls into the runtime.
Yeah, so basically you call it on the method which has the dependency, right? So that's how you can put it as many methods you need. So basically you can have preserve dependency into same member from multiple methods. That again makes sense if your code handles it that way.
What's the scenario for having it on a field?
Presumably the field is declared with an initializer of get member type of, or this.get type, comma, etc. Like, so it has an initializer expression that uses reflection.
So it's effectively putting it on a static constructor. Yeah, I understand.
Arguably, we could say that that's not important and just make that a method and paint it on the method, but I don't see a problem painting it on the field.
Okay.
So is there any reason why the properties are all read-write? Because normally the only property you want to have read-write are the ones that we consider optional for an attribute. I would normally expect member signature, type name, and assembly name to be get only, because you only pass them through the constructor. And then only condition is something you set optionally.
I agree. Member signature, type name, and assembly name. So member signature should be non-nullable. Type name and assembly name should be nullable. And all three of them should be get only.
Yeah, what does null mean? Like even the first, it just preserves what the constructor does, right? But what does the first constructor mean when you pass in null?
I think that should be non-null. Only the type name and assembly name and condition should be nullable.
I think they were, correct me if I'm wrong, but I thought they were nullable so that you could basically say keep everything in that type or that assembly.
I think you say star for that. It does allow some amount of like wildcards.
Which does raise another comment, which is the API of this attribute isn't limited to what we see on the screen. It's also what is the format that's possible for each of these things.
Right.
Also, the namespace is wrong.
Yeah, that's already.
And the name of the type is not ideal.
Yeah.
Yeah.
Because if you look at how we use this type internally today, if method A relies on method B, then you would put this attribute on method B and pass in the member signature of method A. But it sounds like from the discussion that we just had, it's actually reversed.
No, it is put on A. So
this is
you will
the
find
opposite.
this. So for example, you will find this in corelib in places where it reaches out to other assemblies in the framework.
Oh yeah, but I'm saying like right now, if A calls B indirectly, this attribute right now is placed on. Oh no, you're right. You're right. Okay, I'm ignore everything I'm saying.
Steven, you had some like good naming suggestions. Can you maybe bring them up?
I don't remember what they were. My concern was primarily that the preserve part in particular is talking about an action that we expect a particular tool to take in response to this, when in reality, all this is doing is just saying, I have a dependency on something, and something that you're unable to determine otherwise. Do with that information what you will. And something like the linker would then choose to say, okay, well, if I'm going to keep you, I'm going to keep the thing you depend on as well. But other analysis tools would just use that dependency information for other purposes. So the preserve felt wrong to me.
Would requires, or would that word at least be better? Dependency required, or requires dependency?
Or depends on, or has dependency, or implicit dependency, or something along those lines.
Yeah, reflection dependency, non-static dependency,
dynamic dependency.
Dynamic dependency.
Else is dynamically membered access kind of thing. Dynamic dependency.
That sounds like English. Good job, Eric.
Well, the thing is, it's not dynamic. Like, it's known at compile time, clearly.
Well, the code itself is using it dynamically, right?
Sure.
It's depends on what you're referring to as being dynamic. Is it the mechanism, or is it the knowledge of what's the target?
Right, because if you, for example, semi-statically used the keyword dynamic, I have no idea if that works through AOT, but the runtime can't look at it and know what type you used, but you can be like, I'm totally calling that member's toString, or that type's toString. Like, I can see it in the code right now. So you have a static dynamic reference. Yes. So I like dynamic dependency.
I mean, it depends on what you want the thing to communicate, right? I think the idea is that preserve means that don't strip it out, right?
Well, that's how the linker would interpret it. That's my point.
Just maybe one point I would raise is if we make it too universal, we risk that some people will use it in their frameworks for something else, and then linker obviously will keep more than it's necessary because they will just abuse the attribute.
Yeah, that's kind of my point. I think we just had this discussion recently, Stephen, right, on the pure attribute, right, where pure kind of had a very broad semantic, and then different things interpret this differently, and then we ended up with saying, no, we really want an attribute that specifically says don't ignore return type, right? So it seems like we probably want attributes that are a bit more specific on what the mechanical interpretation of this is, and if you want more, you have to apply more attributes.
I see those as being different. The pure thing is actually, the problem is it actually is tied to contracts. Like, that was my main objection to it. So the corollary here would be this being tied to the linker.
So are you implying that you want the word linker somewhere in the API name for clarity?
Me? No, I'm suggesting the opposite. That this thing, the only purpose of this API is to say I have a dependency on something else. Like, I depend on this other thing. The linker then chooses to assume from that, okay, well then I better not remove that other thing if I need it, if I need you. But ILSpy could use that to navigate to the dependency or to show it in your use references. Has nothing to do with preservation.
Yeah, I think it's describing that you have that this member has a dynamic dependency on something else. And yes, you can paint it at too high of a level, and something like ILSpy, it makes no sense for it to jump from there, but you painted it there, and you're describing a relationship between this and something else not dear linker, don't delete this other thing. And the linker interprets that relationship, as could ILSpy or any code or any other sort of tree view type thing of code flow.
I mean, even find all references in VS could respect this, right?
Sure.
Find all references of this thing finds these dependency attributes on other places.
Yeah, it's because it's describing the relationship. And so I think it's good to leave it general and not tie it to the linker. And if somebody abuses it, then fine, they don't link fine, or they don't link cleanly. That's the same as if they type everything as object. Or whatever other things you can do to make the linker angry.
Yeah, I guess as long as we think that this is a very specific and clearly defined thing that this encodes, I think I'm fine with that. I'm just worrying when you have multiple interpretations based on an attribute, right? This is the same thing we had with things like XML serializer, where obsolete now means, you know, hide it from serialization when you really want two different attributes to express these things independently, right? That's my only concern, that we like, if you make it too general, then you bucket decisions together and that you find out later that you want to make independent decisions for those. But I guess dynamic dependency, if it's still very well defined, you just say, I call this other thing at runtime somehow. I think that's fine. It seems very specific.
I don't know the right forum for it, but there probably does need to be discussion about the syntax that's used for all these parameters.
Yeah, I added it as a note. What's the syntax for the signature? It seems wildcards are also supported. Not sure that's discoverable. The linker should at least warn when the string can't be matched. So does it also mean we concluded that member signature should not be nullable, right? That's the other thing we said.
Because it's a required property.
Yeah.
And null makes no sense.
Actually, I just checked that if you pass a null, linker will crash. So yeah, it shouldn't be nullable.
And I would, yeah, I guess saying if we wanted to put a const string hanging off of this of all members, being the asterisk or whatever it is, that would also make sense. And I guess it could still make sense for tools like, I guess really that would only make sense to the linker, but other things could still do something with it, like not show a member as being uncalled because, like, well, something said it has a dependency on everything. So
yeah, that's the problem with this thing, for example, right? Like if you say that you have wildcard support, then I don't know how ILSpy will work.
Right. So is there really a need to do the wildcard?
We definitely have use cases for it. Hold on, let me pull one up.
Okay.
Angry typing.
Yeah, and I mean, again, from a technical perspective, does wildcarding mean public members or all members?
It means everything. Like, keep the whole thing untouched, as in the entire type.
Does it make sense to have a separate attribute just for keep this type around where you could actually pass a type of to that? Or is the idea that you don't necessarily have a type of that you can get at compile time?
Yeah, because didn't we talk, wasn't that the first thing we talked about? A type of and a flags of what you care about?
I think the point of this is, like, if you can do type of, then you don't need this attribute.
Okay. Except this would only keep one member around, and the other thing we talked about keeps categories of members around.
You mean the first attribute we discussed?
Yeah.
Yes, but the use cases are different.
Yeah, so I guess that is one question, is on the two constructors here that take type name, or where we have type name and assembly name, does it make sense to have another constructor that takes type of, and we could certainly make it populate the other two members, but that way you can still get you can have a strong reference to a type that you're just encoding a dynamic member reference to.
I like that.
Yeah, so then, yeah, the only thing really is, I do agree that this is a very long list of things needed on make update delegate, but if we're only going to have a handful of such cases, then maybe it's just worth the cost of splatting them all in like that, if we don't think that the all makes sense in the general case.
Well, I would just look at in our remaining IL-link trim files, like there are various places we use star.
Okay.
I think maybe we got rid of all of them.
How many of those we could replace with the first attribute that we discussed? Because even like when I'm even looking at the the dynamic update delegate or whatever, if we were to rewrite the code so that linker can actually see the text string there, like we are not string formatting things, then you don't even need to annotate, because like this linker could see through if there wasn't like update execute void plus args.length. If there was the proper string that we have up here in the preserve dependency anyway, and you don't need to attribute it. Linker can figure it out.
I think the wildcard question is on Marek actually, because this is used a lot in Xamarin. So, Marek, do you know whether you need the wildcard or?
I'm just looking in like corelib's IL-link trim file, and while we could, so there are various places we use it. One is we use it on to keep around anonymous types, which have unknown names. So there's, we'll basically say anonymous type star to keep around anything that's been generated by the compiler. That's for event source stuff. All the marshallers have stars. There's a star for everything in something to do with component model. Event pipe has a star next to it. This one's just for convenience, but there's like, a bazillion different method builders for async stuff. We need to keep the same two members on each. So we say async task method builder star.
Right. So again, but the question, if the first attribute we discussed today, if it takes a string for the type name, and we just said we have whatever the relationship it was describing against the type, and we keep the whole, like that's the same as using this with a star, is it not?
No, the use cases are different.
Okay.
Like you cannot use the first one we discussed to replace this one, not directly at least.
Say you had a private const string in your type with a fully qualified type name, and then you put on dynamically accessed members and then whatever categories.
Yeah, it would have that effect. I don't know whether we would want to.
I mean, at the end of the day, what's the difference?
It's really hard to read, reason about why did you do that, right? Like it looks
because if we say that this doesn't shouldn't support wildcards in member signature, then because we were making it general, like we can leave it. I'm just asking the design questions here of are we shipping something for a tool, or are we shipping something that's generally useful? And if we think it's really close to generally useful, what are the tweaks we can do that make it meet all the scenarios? And
Eric, I didn't understand your question. Can you repeat it?
So I'm saying we would use this attribute for if you wanted a specific member or like two specific members. But if you wanted like all the properties or all the methods, or in fact the whole type, another way it could be achieved would be private const string whatever the name of the variable you want it to be is, equals some fully qualified type name. And then you slap on dynamically access members attribute from the first discussion with all the members that you needed to preserve on it. And then the linker sees that on that field, and it says, oh, I see this is a fully qualified type name. Let me go look at what members I should preserve on it. Oh, all of them. And so then we wouldn't need the wildcard support in dynamic dependency attribute or preserve dependency attribute.
I thought per your slides earlier, that pattern was recognized by the linker anyway, even without the use of attributes.
Which pattern?
Type of whatever dot get method method name.
Yeah, that is recognized.
That's not what Eric's saying, though.
I must
Eric's
have
suggesting you have a private const string, something I depend on equals quote, foo type, close quote, and then add on top of that the dynamically method attribute, dynamic attribute all, and the linker would see that and say, oh, I see you have a const field that is given the string value foo type, therefore I'm going to keep everything around from foo type. Right, Eric?
Yep.
So the answer is yes, that would work. It's just that it's a very kind of hidden way.
Wouldn't the linker strip out that const?
If it's not accessed anywhere else, it probably would.
Right.
Well, consts are only ever accessed via reflection anyway.
Yeah.
Well, and later stage compiles, but yeah.
Yeah, but I mean, a const is part of the assembly metadata, so people outside of your assembly might query the value, but people within your assembly will never ever dereference the field that has a const value in it.
I think like the answer is you could make it work with some magic. Like, there are certain places where you need to reference a type, and the way you do it is just do type of an assigned to like a discard, right? And so you could do something along those lines here as well. The question is whether it's better to separate wildcards on the attribute we're looking at, or whether we would force people to use this complicated way.
The other option is you kind of combine it instead of having a methods, instead of the first parameter, you have the constructor that takes the member signature, the type name, and the assembly name. You could also have one that takes the type name, the assembly name, and one of those
the kinds
we talked about earlier.
True.
Yeah.
I like that.
Yeah, and then the question is, do you need wildcard support in the type name? And
please don't.
Yeah, I was gonna say, and hopefully no. So.
But I also do like the suggestion, I forget who made it earlier, of having a string member signature and type, like system.type is the second parameter.
Yeah.
And just to clarify, if the type is the type where this attribute has been applied, then you don't need to specify it, right? It's just assumed.
Correct.
Yes.
Okay.
Yeah. Pretend that you could statically say this.getType. Because I pretend that I wish that all the time.
Type of current.
Yeah. Type of this. Magic syntax is the class you're defined in. Right. So that means. So we want the three existing constructors, and then string member signature, comma, type, and then another one with type, comma, whatever flags.
Or whatever flags, comma, either type or string.
Or both.
I mean, it's possible the latter one is speculative. I mean, we'd have to go through and see like what the actual use case for that is. We know we have use cases for the ones on the screen, and also where the type is a type. I would imagine actually the bulk of our current usage would just use type as the second argument.
There's a lot of places in these IL link trim XMLs where it just says type this full name. I'm assuming that means keep that whole type.
Yeah.
I mean, in CoreLib, it's at least 30 to 40% usage.
Right, but was that accurate, or was that I'm tired of typing things?
Sorry, which one are you looking at, Eric? You said there's 30 or 40 that are just type?
30 to 40%.
Oh, 30 to 40%.
In system private CoreLib, IL link trim.
Yeah.
Like almost all of them at the bottom.
Yeah. Right.
So, yeah, so that would be
star, yeah.
Dynamic dependency
star or dynamic members all.
Yeah. Yeah. So that would be dynamic dependency, whatever kinds of flags we called it, dot all, comma type of whatever.
Assuming we had a place to put that attribute, yeah.
Yes. I mean, we could say that we want to open it from method constructor and field to also say class of, don't ask why, but this class depends on something. But like somewhere you have the method that cares and you just slap it somewhere. Yeah. Assembly's weird. Well, by loading this assembly, I assert that this type is going to be used somewhere.
I mean, the cases in a few cases in CoreLib is like the debugger needs this. Right? It's like, well, what method are you going to put that on inside CoreLib that says the debugger is going to need?
Object.get hashcode.
That's true. We've hit this in a variety of cases where we've put preserved dependency on things that we hope are going to get hit on the path to the thing that's actually, going to be used. And a lot of them have to do with debugger.
Right, and that may be a separate private mechanism if we find that there's not a good place that we can put it.
Right, it's something like we could do, we don't want users to do.
Yeah. Can you avoid loading void? Like if this had a class target, you could slap it on. Like if you ever talk about if void ever gets loaded, well, it turns out it has to be. So or string.
You mean system.void?
Yeah.
We're gonna have 100 attributes on system.void.
Yeah, sounds great. No one ever looks at it. So, yeah, I mean, so it's possible we would do an assembly level attribute in the CoreLib that is super special to this tool because of the debugger, but, or yeah, but I don't think that would.
Why do you believe that's specific to CoreLib? I mean, like, wouldn't a higher level assembly have similar issues?
I don't think the debugger is going to be direct calling into anything else in any. I mean, I guess there's a question of like, does the linker need to preserve, or should the linker be preserving, the attribute that says debugger display, go call this other method, and if it is, then that's already covered.
I think I misunderstood what you meant by debugger. Then by debugger, you mean basically the debugger has a private handshake specifically with CoreLib to reach into the runtime to get some state. It's not for making certain types debuggable.
Right, but it does apply more generally to anywhere where some external dependency wants to be able to use something. Like if I have some native code that's going to call into my assembly, or some other something that I know this thing is going to be used by someone. Is there a way that I can attribute it to say like, don't remove this?
Yeah, I mean, if we think it makes sense to widen this to method constructor field and assembly, so that there are places of like, just this needs to be true, and find all references will say, yeah, you loaded system private CoreLib, so this type can't go away. I don't know why it needs it, but that's the relationship. Then that's fine. I'm just trying to think through the tools as well.
Why would you not have an attribute that you just put on the thing you want to keep always? Like basically treat this as a root, never ever link this away. If this assembly is in, this thing is in.
Yeah, I mean, if you had the ability to just say preserve dependency, no, or whatever we call it, but maybe it's not even this attribute, but like the thing that this is applied to should never be removed, period.
Yes.
No dependencies, just like this has to be kept.
Because that seems like what it is, yeah. Because then you also don't need a proxy thing, right? You just put it on the thing it belongs. Don't have any encoding issues. You just put it on the thing, and whether it's a method or an overload or whatever, it doesn't matter.
But that one would be specific to a linker.
Right.
Right. It seems like it would be a different attribute. It wouldn't be this one.
Right.
This one is this thing that I'm putting it on has a dependency somewhere else.
Right. There would be something else that was specific to a linker that was this method or member or whatever must always be emitted. Don't try and elide it.
Right.
Yeah,
So
it's just that we already have a mechanism for that. It's not using attribute. It's this XML. Which
Well, that's what it's all the cases in the XML file. Be nice if there was a way of expressing it in code.
Right. So that would be something like externally referenced, or or something like that.
But here is a case where like we might just need to use it and we wouldn't have to open it up for other people. Right? We could maybe get away with not having something public there.
Yeah. But or again, if it's just the things of like, dear linker, this type can't go away, and it's specific to the linker, maybe that means it just stays in the XML file, and it's a thing for the tool. But it would be nice if we had something standard applied on the things of like, no matter who writes a linker in the future, please don't delete this type because the debugger is you're going to crash the debugger. So.
Thanks for the discussion.
Just speaking of the debugger, we definitely need to have a mode where we remove the debugger support. So there will not be cases just to keep stuff all the time for debugger.
Fair enough. So that means maybe it is still just the XML file, and we figure this out in another couple of years.
No, it kind of isn't though. Well, if you want to move, if we're using the XML file to say always keep this thing in here, but we want to have a mode of the linker to say strip all the debugger stuff out, right? Then we kind of need to mark certain things as like required by debugger kind of.
Oh, okay.
Notation.
Fair enough. So yeah, so maybe that's debugger required is the attribute that we want in that case. But
right.
But I think that on this one, if we drop the wildcard support from it, that we've probably beat this one into either to death or into the shape that we wanted. I'm not sure which.
I have one more question about it though. Have we talked about condition? The last property on this thing?
That's a good point, yeah.
How does that have another half an hour, then I guess yes.
I mean, I assume that this is supposed to be that you want this to be like the conditional attribute, but conditionally applying this attribute. Am I wrong?
Actually, the way it works currently is that's the debugger support. You can say debug there, and it will be kept only when the linker is asked to keep debugger support around. And so
it's like a defined constant.
Yeah, it's very specific right now.
So it's like the conditional attribute. It is the attribute conditional attribute,
yes.
But then a specific variant of it for this thing. Yeah. So that is exactly what I guessed from that, and so it seems fine to me.
But it's not like an expression of any sort, right? Like greater than equals less than.
At least literally not right now. Currently in the linker, it only supports a single value that is debug.
Yeah. So what did we call it on the conditional attribute? We called it condition string, so condition's fine.
Condition string, Jesus.
Yeah.
Yeah. I mean, I would say condition is not great because it kind of implies like a predicate or something, right? Probably conditional symbol would be better, or some whatever, or preprocessor symbol, whatever the thing is called in C#. Because that's what it maps to, right?
No, that's not what it maps to, unfortunately.
So debug does not mean debug is set. It means something that is unrelated to that.
as Marek suggested, there's a mode for the linker where it tries to strip stuff which is necessary only for debuggers. And if you say debug, it means keep this only if you're not stripping for debuggers. So, like, we support debugging release code, right? And so if you actually run the linker on an app with like strip debugging, then debugging it even debugging that version will be pretty bad. Like you probably will lose all the visualizers, for example.
Yeah, I think the motivation was basically to give the flexibility to describe even further the dynamic dependency conditional. So, for example, you can use this for, let's say, serialization in theory, where you say, okay, I need this dependency only when I'm running in, I don't know, serialization dynamic mode or something like that.
Or like a user could do it if they had two applications, right? Like, and I have this dynamic dependency only in app 1, so I'm going to set that when I link app 1. But when I link app 2, I'm not going to set it, and then it's gone.
But it's sort of like defined constants. It's just that possibly it wouldn't be using the same value out of the CS proj.
Yes,
and it's
true.
link time.
Right.
Right.
But I mean, it does raise the question, like, condition to me implies either even if we do it after the conditional where it's just a single string or meaning a single symbol, whatever that symbol means. But like over time, if you need to support multiple things, will you ever have something like debug, comma, profiler, comma, whatever? Or is this always going to be a singular string?
I would think a comma or semicolon or whatever syntax we want to support for a list would be reasonable. Of if any of these is true, this is true.
Yeah, in which case it probably should be like, I don't know, conditions or something. I mean, the question really becomes, right? Will you ever have something like, not debug or this, but not this and this or that? Because then it becomes its own mini DSL. But maybe condition is fine.
You could put multiple on, right? You'd put multiple on if you wanted the or.
I guess.
Fair enough. I guess allow multiple is true because you could have had multiple different dependencies anyway. So, yeah. So that may be fair. So condition may be single dependency, and there's no anding. If you need anding, then you need to do complicated stuff yourself.
Another condition. That's both of them.
So.
Okay, I'm fine with I think conditions fine.
Yeah, it did exactly what I thought it meant. Just it's not necessarily using the same value out of the CS proj. So that's more a tooling experience, but semantically it matched with my expectations. So it passes that litmus test.
Okay, I have no more questions.
Sorry, Levi, we still didn't get to your thing.
That's fine. I'll just check it in and deal with the consequences.
All right, so let me just quickly paste the notes and make sure that they're accurate.
And we currently can't see your notes.
No, you can't. I mean, I can barely see my own notes. Man, 100% CPU utilization sucks. Everything is delayed. Here we are.
All right, you missed all the other constructors we said it should have.
What are all the other constructors?
Member name, comma type, and the binding flags that we had from the first attribute, comma type, and the binding flags we had for the first attribute, comma type name, and the binding flags from the first one, comma type name, comma assembly name.
Okay, so let me get this right.
If the type's always going to be in the same assembly when you only have the two, when you just have member signature and type name, if it's always going to be the same assembly, why can't you reference the type hard? Do you know what I mean? Like in the...
Yeah, I think it makes sense to not have the middle one. Doesn't that, if you have the system.type one.
Right. Only
Okay.
have the string type if you need to take in the string assembly.
Is another tip, don't have two displays at different DPI settings. Makes dragging impossible. All right, so I heard type and then I heard binding flags. What else was there?
Well, was binding flags what we actually used on the first attribute we talked about?
No, it
No,
was dynamic member,
Yeah,
dynamic accessed member kinds.
so that would be that one.
All right, so I think we just deleted line 21.
Yes.
Let's finish line
Yeah.
25. This would replace string member signature.
So we removed this one here, is that what he said? Or this one?
No, 21.
21, okay.
And then on line 24, the third parameter replaces the first one.
True.
I'm
You
confused.
don't need a string. You don't need a string member signature. So delete that and put dynamic access member kinds into the first slot.
I see. Okay, so we just swap this guy.
And then you need one for 21 as well, like that.
Yeah.
That would be... Oh, that was the one. Never mind.
So then now we need a dynamically accessed member kinds nullable property, and member signature becomes nullable as the property.
Do we need a member kinds for number 20 as well, for line 20 on this type? Or is that?
It feels like you're pushing it.
Yeah, kind of. For the current type.
Yeah, if we need it later, we can try adding it back. But who puts somewhere on their type, if you called something on my type, we need the whole rest of the type. And like maybe it would make sense, but I think we can bring that one back if we need it.
I mean, that would solve the case where we were like, we don't have a place to put this attribute.
Maybe, but if it was for things like the debugger is going to directly reference this, or the debugger has a hook to call this member that you don't see, like the linker would have already stripped it out because the debugger didn't. Like it doesn't see any call to it, so the dynamic dependency doesn't resolve. Unless we said dynamically depending on yourself means you're a root, but that feels hacky. So I think this covers the things we talked about.
All right, so we covered everything then except for requires unreferenced code attribute. So I guess we should cover that next week again then.
Sounds good.
Cool, then I will invite the same set of people for next Thursday, I believe. Because next Tuesday is already taken. And then we will also cover Maoni's get GC info unless we can do it over email.
And Emo, I just, on the ASN reader writer thing, posted the diff of what the API looks like now that I've responded to feedback. I don't know what mechanism we want to react to that on.
How bad is it?
But, I mean, we changed everything, but a lot of it is simple shape changes. So I don't know if it's email or if it's.
I mean, if it's literally
just
the response to what we said in the meeting, then I don't think we need a review. But like, if there was some feedback, like think about X, and then you thought about X, and you have a proposal for X, I think that's different. But
yeah, well, like replace the ref struct with static methods means here's what all the static methods look like now. So
yeah, I think those are fine. I mean, we usually don't do 2 passes, right? We usually tell people like, here's the things you should probably fix, and then that's the end of it.
Okay.
I mean, it's only really for like, oh, we don't know what the design would look like. I think everybody can visualize what having static methods would look like.
Okay. I did have one more concept change with it. If I took the options to control some of the overloads with defaults, but anyway, I'm just take a look at the update I just did to it and see how you feel. And this is just more for the planning for the future meetings. So
sounds good. Then I think this is it for
I'll
today.
send you an email on it.
And then goodbye, everyone.
Auf Wiedersehen.